Welcome to the Prepared for Environmental Change webinar series. My name is Andrea Webster. Today's webinar is on managing extreme heat. I think you all know quite a bit about that. It's been quite hot here in Indiana and probably across the country. So before we get started, I want to let you know that everyone is muted. And if you have a question, you can enter it into the chat function, which you can access by hovering your mouse over the Zoom window, and you should see a chat option appear. We will be live tweeting today's webinar, so if you'd like to share our tweets or retweet them in the lingo that Twitter uses, you can use @preparedforchange. We are recording today's webinar, and I'll share a link to that recording along with follow-up resources with all the registrants, probably Friday or Monday next week. And finally, I'm very pleased to introduce the director of the Environmental Resilience Institute, Janet McCabe. Janet will be our moderator today.
Hi, everybody. It's great to have you here on this hot, hot day. This is a very timely topic as we all swelter in Indiana summer. Here in Indianapolis, where I live, we've already had many days of 90-degree temperatures, and more are predicted. I just looked at my phone. It's 90 here now, according to my phone. And we all know that hot weather can be really dangerous for people who work outside, people without air conditioning, or with health conditions that make them more vulnerable. And in these days of the COVID virus, a lot of the places that people might go to cool off, like malls and libraries and other public spaces, may not be available to them, or people just are reluctant to go to them because they're concerned about putting themselves at risk of being exposed to the virus. So very challenging time. Hot weather also increases air pollution. It affects our green spaces. It also affects our mood. And there's studies associating increases in violence with hot temperatures. So there's a lot to be concerned about and to learn about what's happening with temperatures in our country and in our state, and how that might affect us, and things that we can do to help our fellow Hoosiers and others deal with these hot temperatures. So today we have two very talented practitioners, Vivek Shandas and Colleen Moran, who will share their expertise on how to manage extreme heat in your communities. All of us are very familiar with extreme heat at the moment, but the fact is that our work around the state has revealed that that communities are not as focused on preparing themselves or their residents for more frequent heat as we might think they ought to be. And we understand that there's a lot going on and people have to prioritize and can't focus on everything at once. But I think that the virus has given us all a really important lesson that we can't just wait for a particular issue to be numero uno on our to-do list because people are going to the hospital. And that preparation and knowing the information you need to know so that you can be prepared are really, really critical. So you guys know that because you've decided to join us today so that you can learn about this and help implement some of the ideas you hear today, I hope. So let's go to slide 2. In addition to our webinar series, I just want to make sure that everybody knows that ERI has many other resources to help you as you're thinking about resilience in whatever capacity you work. So you can please go to our website and look at these resources, or you can, in your the time that you have for podcasts, you can listen to our podcast, which is fun, and check out the journalism that is produced on a regular basis at the Indiana Environmental Reporter. So we're proud of these resources and hope that you'll find them useful. We do have some webinars coming up, but I'll let you know that we're taking a hiatus in August. Everybody needs a little time off. We will be asking people to give us your ideas about the topics that you want to hear for future webinars. So we will look forward to getting your input on that because we want these to be useful. We want to thank the Association of Indiana Accelerate Indiana Municipalities and the Association for Indiana Counties for continuing to support the webinar series. While everybody is welcome, to use the resources and to attend these webinars. The Environmental Resilience Institute does have a focus on assisting local governments in Indiana and the Midwest. And so these partnerships are really important to us. We also want to thank the Indiana Public Health Association and Health by Design for their support and sponsorship. And a topic like this is especially important for local health departments and organizations that focus on public health around the state. We have lots and lots of people registered for today's webinar from across Indiana and even from elsewhere in the United States. It's always fun to see where we have people joining us from. So we're thrilled to have you join us. Thank you. Please spread the word if you find this useful. And remember that we have all of our past webinars archived on our website, and you can go listen to any ones that are of interest to you. So I'm going to briefly introduce our two presenters, and then I'm just going to hand it off to them, and you won't hear from me again, likely until the end. We do have the ability to, we will have questions, time for questions at the end, which you can do either through the chat function, or Andrea will unmute people, or you can unmute yourself to ask a question. But if you think of something, I'm tempted to say a burning question as we're going through the webinar, please do enter it into the chat box when you think of it, so you don't have to be distracted trying to remember it. And if it's something that we think is really necessary to stop the flow, we'll interrupt and ask that question for clarification. Otherwise, we'll tee them up for the end. So our first speaker will be Vivek Chandas. He's a professor of climate adaptation and the research director for the Institute for Sustainable Solutions at Portland State University. He studies the effects of urban development patterns and processes on environmental health. By examining the assumptions about our built environment, Dr. Chandas supports communities in improving their adaptation to climate stressors, including extreme events such as urban heat, air quality, and storms, right up our alley. He is the chair of the City of Portland's Urban Forestry Commission and is a principal at an organization called Capa Strategies, LLC, which is a global consulting group that helps communities prepare for climate-induced disruptions. Next, we will hear from Colleen Moran. She has 7 years of experience working on the human health impacts of climate change at the Wisconsin Department of Health Services. In her current role as the Strategic Initiatives Coordinator for the Bureau of Environmental and Occupational Health, Colleen supports and promotes the inclusion of climate change and equity into the work done at the Wisconsin Division of Public Health. Previously, she served as the Climate and Health Program Manager in this division. So with that, I want to thank both our speakers for joining us today, sharing their expertise and learning with us. And I will turn it over to Vivek to share his screen and take it away.
Okay, thank you for that generous introduction. I am delighted to be here with you. I hope my sound is coming through okay, and all our Zoom technical capacities are at full tilt here. My name is Vivek Chandas. I'm a professor, wearing a hat as a professor of climate adaptation at Portland State University and a principal at Capa Strategies. And before I get started into this localizing climate effects from urban heat, stressors on and strategies for creating a more equitable region, I just want to thank several groups like the Climate Resiliency Fund, NOAA, who has been very supportive of this work, U.S. Forest Service through their National Urban Community Forestry Challenge Grant, as well as National Science Foundation, and so many other, and of course, a lot of grad students and other staff that have been instrumental in getting this work. So I am but a messenger here of lots of work that's happened by people who are far more talented than I in much of this work. So with that, I'd love to just start by finding out a little bit about why you're here. And if you would, Andrea, if you could try to run a little poll where I'm asking through Zoom, we're gonna try and see if this works. Looks like mine showed up. Which of the following best describes your interest in attending today? And if you just choose one, actually we could just, if you could just do the first one for now. I see all the polls are there, all three questions, but just the first one that you see, there's question number 2 we'll wait on for a little bit, but just the first one, if you could answer that. And I think Andrea can post those results in a minute here. All right. Oops. See if that worked and if we got a high percentage of people responding. Could publish the poll and see where we are. Curious why you're here.
So votes are slowly coming in. We're under 10%, but I think it's jumping up rapidly. So I'll give folks another minute or so.
Warm weather does slow us down a little bit, so that's okay. Take your time and we'll get through this.
Okay, so I'll give you guys about 5 more seconds and then I'll end the polling.
Okay, thank you. We have any results? I'm so curious. Do you know how to post those up? There you go. Great. Oh, okay. Learn about the topic. Sounds like looks like it's number 1. And no one wants to boost their career, it looks like. But we do have people who are, and no one's boss is making them do this. That's fabulous. So you're here on your own will and interest. Good. All right. Well, thanks. Thanks, everybody. I will kind of continue in with this. So if you want to learn a little bit about this topic, I'll tell you, starting with our group, we're the LLC that I've started. I'm calling myself a pracademic for this, is doing a lot of practitioner work as well as some of the academic basic research. And Capa stands for Climate Adaptation Planning and Analytics. And we're really doing 3 things. We're trying to engage communities by localizing climate-induced hazards. We're developing some analytical tools for examining scenarios. And then we're aiming to build capacity through engagement of decision makers and community groups. And so those are kind of the 3 pillars around which most of this work is happening. Today, I'll really be spending most of the time on the Heat Watch program and kind of talking about why do we even want to get into this topic of urban heat. And then I'm delighted that Colleen is going to be following with aspects of the health as well as some tools that are going to be available to you, it sounds like, for applying to this topic. So the big question that I keep hearing when I'm out in the community, we've been now engaged in about 40 different communities, namely cities around the country. And big question that I see asked is, what are the effects of climate change on my region? And that's one of those large questions that's really unwieldy. It's very complex, a lot of uncertainties, and very limited data on this as well. Although we continue to gather data, there's still lots that needs to be done. And then ultimately, the goal of this question, I think, is to move into the policy realms and trying to address these impacts and even get in front of some of these impacts. And so from that, what we've been spending a lot of our time on is thinking about what will the future look like in many of these regions. And so I was really thrilled to see some work coming out of University of Maryland last year, where a couple of climate scientists essentially looked at climate analogs. So what will Indianapolis look like, for example, in 2060? What will Madison, Wisconsin? What will Minneapolis? And essentially looking at these 540 North American urban areas, they were able to essentially say, what will the weather on a day-to-day basis essentially represent? And what's interesting is the American Society for Civil Engineers has really been moving a lot of their code for buildings and things like that to follow some of these future development or future climate trends. And that's just in early stages. Haven't seen a great deal coming out on the ground yet in terms of climate friendly or climate sensitive buildings. Though what I do see is if this little tool that's been created as part of that paper was essentially choosing an area and saying, what will this area look like in 2080, 2060, and moving towards the end of the century. And for Indianapolis, at least, what I was looking at here for this tool essentially looks like it's going to be northeastern Arkansas. So lots of this moving south, lots of the temperature, of course, moving south because of these warmer climates, and trying to get a gauge on kind of what that means in terms of the frequency and intensity and duration of various climate-induced events such as floods and heat waves, the latter of which I'll be talking about now. So just a little, I do wear a professor hat for once, so just indulge me in my professorship for just one minute while I just at least give you some of the fundamentals of the work that we're getting into, and that is trying to understand what's happening on the ground. Generally speaking, what we're really getting at with our heat assessments, and even to a certain extent, any weather-based assessments, meteorological assessments, we're thinking about the sun's radiation coming down in this short, very energy-filled packets into the earth, and a lot of that warms the surface, so that's this ground heat. Some of it warms the air, and some of it warms the water. And so there are these different ways of describing that shortwave radiation as it interacts with our atmosphere as well as our surface. A lot of that is bounced back from clouds, from surfaces, etc. And that really allows us then to quantify the amount of heat, kind of a thermal budget, if you will, on the ground. And there's a whole field of thermodynamics, planetary thermodynamics, that's been instrumental in a lot of the climate models that have been developed to get at this phenomenon, and they're being improved by every day. So this really translates on a planetary scale, and what a lot of our work is trying to do is get down to the neighborhood scale. And what we're seeing is that this phenomenon of heat coming onto the surfaces that we build in our cities and regions, it really interacts with these surfaces in a variety of different ways. Buildings, the materials they're made of, trees, the number of them, their distribution, whether you have water or any kinds of water bodies in and around your region really matters. And of course, the movement of air and how well that movement of air works matters a great deal as well. And so anthropogenic sources such as air conditioners, cars, other things that humans do also add to that kind of distribution of heat, or at least what you and I would experience as we're walking around a region or a neighborhood. And so this helps us get to recognize that this is not a new thing. People have been studying this, and I don't want to spend too much time on this, but just to illustrate that there's a long history of studying heat in urban areas. And this is historically looking at differences between city and surrounding areas. That's kind of the classic urban heat island, where nighttime temperatures stay warm, whereas surrounding areas cool. And current descriptions, however, that we've been trying to push with our team has been about trying to describe the causes for the differences in heat that we see within a city and across cities. And that's really getting at how do we use land use policies, how do we use the physical infrastructure, how do we think about the distribution of people in space such that we can reduce the likelihood of impacts of heat, which, as you'll hear from Colleen, kills more people annually than all other natural disasters. And so when we're per year, and so when we're talking about heat, there is this long history, though people are still we're still seeing excess mortality and morbidity as a result of heat waves. So in many methodological as well as design tools that are developed, though, again, that's a very early stage in what's happening. Last bit that I'll say, at least from my academic side, before I transition to the practitioner side, is that these traditional approaches have really used satellite imagery and differences, as I mentioned, nighttime temperatures, but satellite imagery has been a large part of how we've assessed urban heat, at least since various satellites like MODIS and others have been launched. More recently, NASA's launched a Landsat 8, which has a ability to actually look at surface temperatures. And so what we're getting at is that skin temperature. So rooftops of buildings, not necessarily on the ground, you get not necessarily what you and I experience, but rooftops of buildings, roadways, driveways, lawns, forests, etc., the tops of trees. That's essentially what a satellite is picking up on. More recently, the work has started to integrate the satellite imagery with ground-based measurements to try to develop a more real feel, if you will, of what the temperatures are like when you and I are in and around a neighborhood or infrastructure is interacting with that ambient temperature and humidity. And that's kind of the classic common descriptions of UHI. We've been trying to move into a community-based assessment, trying to get communities to participate in collecting heat data, heat and humidity data. And I want to spend the rest of the time talking about that. However, before I do that, I might just ask a quick question. Why might we want to engage a community in doing this work? We have satellites to do it. We have plenty of history of research in doing it. So why might we want to engage? Poll number 2 is, why might we want to engage a community in collecting temperatures and describing the local distribution of heat? So if you just take a quick minute and see if it's any of these. Is it to connect different groups and sectors to a common threat? Is it to provide insights into the scientific process? Could it be gaining insights about how different land uses mediate temperatures? Could it be about generating civic legitimacy for advancing climate actions? Or how about creating momentum for taking mitigative actions at the local level, or is it all of the above? So just take a minute and let, if you would, Andrea, if you could launch this poll one more time so that we can see the question number 2 of the list. So if you scroll down to question number 2, you'll see these same questions appear on that poll. And if you just choose one of those real quick, I think this is one that you'll probably be able to do somewhat quickly, but let's see. If you just
Vivek, we heard from some people that they had to answer all the questions in order to be able to submit their answers.
Oh,
but they can, looks like they can go ahead and vote again
okay.
now that they're more informed by your remarks.
Okay, thank you. I did not know that. Okay. I want to vote again and see if we could look at poll number 2.
All right, we'll give you guys about 5 more seconds.
Thank you. All right. And looks like if we scroll down, looks like all of the above. This was kind of a gimme. There are some other reasons to do this as well, of course, and there are priorities that one could prioritize within this, like creating momentum for mitigative action seems to be one area that's definitely of interest, and I've been hearing that a lot from community groups as well. So let me go down and keep going here. That was a chance. So we do this community-based assessment to really do all of those things and to really show that there is a process by which you can bring communities together, start talking about what's happening in our region. And then what we do is we create these specific approaches where we actually engage the communities in a community science approach where they're essentially instrumenting their vehicles or their bicycles with sensors, very sensitive sensors. They go out and collect hundreds of thousands of individual temperature, humidity measurements. You may have seen some of this showing up in various media publications recently. And then that really helps us to come back to this climate resiliency planning after the analytics of each of those measurement techniques. And so that's been a means by which we've started to collect temperatures and reasons why we might do it, though there's a more insidious reason, I think, that we do this, and that has a lot to do with the historic echoes of land use planning that's occurred in cities around the country. Just like Minneapolis and Indianapolis here as 2 examples, cities around the country in the 1930s were, as you might well know, were essentially provided funds and support and a federal policy to create these specific areas called grades. They were grades A, B, C, and D. And from the 1930s all the way up to the mid-1960s, this policy existed as a direct way of being able to encourage development in some areas and not encourage development in other areas. And so what we're noticing in a lot of these places that were historically redlined, as you notice the red polygons in both of these maps, were areas where often communities of color, historically underserved communities, immigrant communities, Black, African-American communities were often living, and those were the areas essentially segregated from other parts of the city in redline zones. And so this really insidious act and directly racially motivated act was a very direct attempt at allowing some communities to be distanced from other communities. And those communities that were requesting the distance were often those that had access to political power, access to financial resources, and a lot of disinterest in wanting to interact with communities that were in these red-lined areas of each city. And so this historic policy that really lasted for over 40 years set in stone and baked in many respects, the temperatures that we see today. In fact, what we saw when we looked at a recent study, we looked at 108 red line cities, and what we found was that there are big temperature differences between the D, if you look at the bottom, Hulk security rating is what it was called. The D is in the far right, C, B, and A. We find that the D is generally hotter land surface temperatures versus the A zones by almost 5 degrees is what we were noticing in many of the regions. And then in the B graph down below, you see the percentage of land use type, and the gray represents impervious surface, or concrete, if you will, asphalt, and the green represents trees or any kind of greenery, lawns, watered lawns, or trees. And we were able to look using satellite imagery at the distribution of impervious surface, asphalt, concrete, and greenery, and we found a very similar pattern across all 108 cities as well. And so this really got us thinking that what we're experiencing today in terms of temperatures around the city really isn't really about what happened yesterday or day before. It's really what's been a systematic pattern that's played out from the 1930s and maybe even earlier. So this work has really helped us to kind of further support the community-based efforts that we're engaged with, because in many respects, when you look at the cities, and these are some aerial views of cities, of regions in the Midwest that have had both redlined and non-redlined areas, and what we see is a very different kind of landscape signature, if you will. You see a lot more canopy in some areas, a lot more kind of manicured and well kept, and then other areas that are far less canopied and far less kept. And often this has to do with the amount of investment that went into these areas from local municipalities. And these are stark images to help remind me that this work that we're doing is really for the community and with the community. And so with that, what we do in a nutshell, and there's some videos and other things I'm happy to share about this, but I just want to go through this relatively quick since there's plenty of material out there on this work, where we engage a community. It's usually a city or a nonprofit in a local area, and we essentially guide communities through this recruitment of volunteers. We provide these study areas, these polygons, if you will, where people can go out and collect temperatures. And then we provide training as well as equipment to be able to go out and collect temperatures throughout these areas. People who are participating in this campaigns go out at 6 a.m., 3 p.m., and 7 p.m. So we get a full diurnal profile of the heat as it really bakes into some areas over the day and then dissipates really fast in other areas throughout the night, whereas stays hot throughout the day and doesn't really dissipate in other areas as well. There's often navigators helping with this work, and volunteers return the equipment. We actually have Cincinnati, one of the partner cities of this group, going this year, as well as Detroit as another city cohort running this campaign this year. Finally, we generate a report, do some machine learning analysis on, we don't interpolate the data, we actually do a very interesting and well scientifically defensible technique of machine learning algorithms that take these temperature and humidity as well as satellite imagery to describe why these specific temperatures and humidities are what they are in specific locations. We work then back with a volunteer survey, organizer survey, to try to understand what we did. And this is a report from last year's Honolulu campaign, which was a tremendous success for at least the local galvanizing around urban heat. These are some of the results. Folks go, this is Boston, Massachusetts, folks go all around the region collecting these temperatures. We're able to see those temperatures. In this case, 109 was the high temperature. 102.3 was a high temperature in 2019, at least for that particular day. It's one day where people go out. In this case, it was 2 days because they wanted to get a larger expanse of where it is that they're wanting to do some interventions. And then we create these surfaces, these full kind of descriptions of what's going on in and around each of these. And you see how that changes from 6 a.m. in the far left to 3 p.m. in the middle, and then 7 p.m. in the evening. So that's at least some of the outputs. There's some strengths to ground-based measurements. We believe this is it engages communities in their place. We're kind of creating the civic legitimacy, and we're also providing these high resolution outputs from the results of what people feel in the diurnal periods of the day, throughout the day. And then of course the policy applications are relatively evident. There are a few weaknesses that we'll openly admit to, and that's the coordination of local community groups requires a person usually to coordinate that effort, take some time and strategy. It's not free, unlike satellite imagery, which is free, although it requires some technical prowess, certainly. There are seasonal differences we haven't yet been able to do between winter and summer, for example. And then if there are clouds and things like that, it can really delay or slow down the collection of data. And finally, these generalizable models for entire regions are still not there. We're still developing those. And that's a matter of time before we come up with those. Nevertheless, we just wanted to kind of get a sense for what some of the strengths and weaknesses are. So the last poll, I think we already have results for this last poll, which is which organizations might help to coordinate a heat field campaign in summer 2021 in your region, if that's something that you would be wanting to explore. I would ask Andrea maybe just to push the poll results up now, since I saw that they were already submitted, and as we heard earlier, we can maybe get those poll results for number 3. And it looks like public health agencies, university research organizations, or even regional or state public agency could play a role. That's great. We've seen this happen from a variety of different perspectives. Folks who are science museums, for example, have been very involved. Various climate or environmental justice organizations have been involved. So there's lots of different ways in which these campaigns can move forward and coordination can happen. So with that, let me just kind of close out with a couple of results of these campaigns. Like Richmond 300 included some of the results in their heat vulnerability assessment as they're redesigning parts of their city, looking at ways to improve the design of buildings to mitigate some of the heat. And to kind of segue into Colleen's discussion now, we've been building a series of tools based on these results of these campaigns, where we're looking at social vulnerability as a result of these heat maps that we create, as well as scenarios where we're actually looking at what if you were to pave over an entire region, or green a region, or put in green roofs or other kinds of whitening of surfaces. What would that do to this specific city block or this specific neighborhood? And then finally, a lot of urban forestry groups have been interested in trying to understand what would happen when you put trees in this area, or where could we put trees in this specific area. And so we've been busy building tools for various outcomes and directions that I think you'll hear a little more from Colleen. Just one example, in Washington, D.C. last year, we were looking at one area that was undergoing some potential redevelopment. This is a public housing development. And what we did with that heat map is the local planners and public health agency staff identified this neighborhood as being an area that's particularly prime for heat stress. And so we were able to run these essentially computational fluid dynamics models to better describe what would happen in terms of the temperature and the humidity given different scenarios. That's what you see the graphs on the right. The blue line being the base case, what is there right now, and then different scenarios in terms of what you would do in terms of greening or green roofs or lightning surfaces, etc. So there's several different tools like this that we've been actively deploying to be able to support community decision-making about what to do in a place that might be particularly hot, and some of the communities may be facing some severe health consequences as a result. So with that, I just close with, I kind of capture this all in a shameless plug for a book we published last year of looking at urban climate adaptation and the role of urban form. And a lot of these modeling tools, as well as community engagement tools, are in this. And it's kind of takes you through a 5-step process, and happy to chat about that as well. So with that, some contact info about me, and I'll turn it back over to Andrea, and maybe directly over to Colleen as I conclude. Thank you for your attention. Really appreciate this opportunity.
Thanks, Vivek. We'll just go straight to Colleen.
So before I get started, I want to confirm that you are seeing the correct presentation screen. Does that sound right? Okay, I got a thumbs up from Vivek. Okay, so thank you so much for inviting me to speak with you today. This is very exciting. I don't often get to share my public health knowledge with non-public health folks, so it does look like there's a few attendees who are in the world of public health or medicine, so that's exciting. And I was excited to see that Vivek's third poll, the highest rated, who should we be working with, was your public health agency. So I concur. Please reach out to your public health agency, whether it's local or state. We love to talk to you. Okay, so we don't have a lot of time left this morning. Where I am, I'm in Central Standard Time here in Wisconsin. So I'm just gonna get going. Brief overview of what I'm gonna talk to you about today. First, I'm gonna give a very brief, what are the human health impacts of extreme heat 101? Just spend a couple minutes on that because I assume most of you already know all of that. And then I'm going to spend the majority of my time talking to you about some extreme heat tools that the Climate and Health Program at the Wisconsin Department of Health Services has created that I'm hoping might be useful for you, depending on what your role is. So the very brief Climate and Health 101. So as Vivek mentioned, we are extremely concerned with extreme heat events. Even in the upper Midwest, even though they don't get a lot of play, we know that extreme heat events are dangerous and deadly. And as Vivek mentioned, more people die from extreme heat related causes in the US than any other extreme weather topic. And based on climate change projections, more heat events are likely to come, with extreme heat events becoming more frequent and more intense. The effects of extreme heat, like most climate change impacts, are not felt equally. And those photos that Vivek showed, those aerial photos, were a really stark reminder of that. Certain populations are at greater risk. And for some historical context, the 1995 extreme heat wave was very notable in the Midwest. An estimated 700 people died from heat-related illness in Chicago, and 91 folks died in Milwaukee, Wisconsin that summer. So it's a huge issue. People die from this. I just wanted to step back a little bit and give a little context on the Climate and Health Program at the Wisconsin Department of Health Services, which is where all of these tools and resources come from. So the Wisconsin Climate and Health Program is 100% federally funded from the Centers for Disease Control and Prevention through a program called Building Resiliency Against Climate Effects. And the map that you see on your screen there highlights the 16 states and 2 cities that are funded through this funding opportunity. We've had funding since 2012 and are just about to start our 5th year of a 5-year competitive grant cycle and are hoping for continued funding in the future because this work is so incredibly important. So first off, before we go any further, I do want to acknowledge and thank WICI, which is the Wisconsin Initiative on Climate Change Impacts. It's an organization that we've been partnering with since the inception of the Climate and Health Program. They do provide all of the climate projections and climate-related data that the Climate and Health Program uses. So the data that I'm going to show you momentarily comes from our partners over at WICI. So Wisconsin's climate, much like that of the rest of the Midwest, has shifted and has warmed by 2 to 3 degrees Fahrenheit since 1950. This warming trend that we're seeing is expected to continue for years to come. Depending on the emission scenario we end up with in the future, Wisconsin may warm by anywhere between 3 to 8 degrees Fahrenheit by the year 2050. The frequency of very hot days is also expected to increase. The figure on the left shows the historical annual number of days above 90 degrees Fahrenheit. We can compare that to the figure on the right, which shows the projected annual number of days above 90 degrees from 2041 to 2060 under high emissions conditions. So the key message here is that with this pair of maps is that the number of extreme heat days approximately triples in the future. Well, there are many human health impacts of climate change in Wisconsin and the upper Midwest, including those on this slide, like extreme cold and winter storms, increases in precipitation and flooding events, vector-borne disease increases, mental health impacts, economic impacts, and power outages, which have a myriad of negative human health effects. For today's presentation, we're just going to focus on the human health impacts of extreme heat. So extreme heat has the potential effects, as we already discussed, of heat-related fatalities, but it also can cause heat stress and fainting. It can exacerbate many chronic disease conditions. And there are other human health-related impacts from extreme heat. Changes in surface water and groundwater can occur. Negative effects can occur to patients who take some mental health medications. And as I mentioned, power outages can occur during extreme heat events, and that can have huge impacts for folks relying on medical equipment. certain factors can increase one's risk of heat-related illness and death. The biggest one of these factors is age. So infants, young children, and older populations are at higher risk of heat-related illness, though there are other vulnerable groups, including outdoor workers, those with cardiovascular disease or hypertension, pregnant women, and anyone taking certain medications. And I do want to mention, before moving on, related to what Vivek was talking about, the human health impacts of climate change are not felt equally. They are disproportionately felt by some populations. So in order to focus our work at the Climate and Health Program at the Division of Public Health in Wisconsin on this health equity work, we're directing our efforts to working with priority populations. And these populations were highlighted in the 2016 report from the US Global Change Research Program entitled Climate and Health Assessment, and include those with low income, communities of color, immigrant groups, including those with limited English proficiency, Indigenous peoples, children and pregnant women, older adults, vulnerable occupational groups, persons with disabilities, and persons with pre-existing or chronic medical conditions. So with that, I'm going to switch gears, and that was sort of the end of what are the human health impacts of extreme heat. And now I want to talk about what are the tools that the Climate and Health Program has created to assist with preparing for and responding to these events. So we do have a suite of tools. We have an extreme heat toolkit. We have created a heat vulnerability index. And I briefly want to talk about a type of rapid needs assessment called the Community Assessment of Public Health Emergency Response, which is a mouthful. And so the fun little acronym the CDC developed for that is CASPR. I also threw a fourth toolkit into the mix, hoping that that might be something that could be used for extreme heat in local communities as well. So first I'm going to talk about our extreme heat toolkit. So as I mentioned, the Climate and Health Program, the Wisconsin Department of Health Services, has a whole suite of extreme weather toolkits. They include extreme heat, which we're going to talk about today, winter weather, thunderstorms and tornadoes, drought, wildfire, vector-borne disease, flood, and chemical releases. And these are all publicly available on our website for download. And I think that Andrea has either already shared these tools with you or will when she sends out the summary later in the week. So the target audience for these tools are local public health professionals and local government officials. The objective of the tool is to outline the health impacts of these various extreme weather events and how to respond to them. And the tools all include response checklists, talking points for responding to the media, and message maps. So delving a little bit more deeply into the extreme heat toolkit. So all of the toolkits start with a brief summary of the historical and climate projections in Wisconsin related to the topic at hand. I don't think they'd be vastly different for Indiana, so feel free to steal these. The extreme heat toolkit contains the following individually downloadable PDF guides. So if you just want to download and use a portion of this rather than the whole entire toolkit, that's also possible. So we have heat alert definitions, heat illness and symptoms, extreme heat tips, populations vulnerable to heat, checklists for extreme heat, and talking points and message maps. And I just wanted to mention that in addition to each of these extreme weather toolkits, there's an accompanying one-pager with the target population being the general public on tips of how to keep your family safe. And these are available in both English and Spanish. I did want to mention, and I know Janet mentioned this in the intro, given COVID-19, there are COVID-19 considerations that need to be taken into account. Our toolkit has not been updated to include those considerations, but my suggestion to you would be to reach out to your local public health agency or state public health agency for tips on how to thoughtfully and carefully prepare for and respond to extreme heat events right now, because we don't want our cooling shelters to be a source of virus transmission. So for example, the Wisconsin Department of Health Services does have a lot of information available related to this. And again, I would just suggest you reach out to your local public health or your state public health agency to get more information about how to do this. So the next tool I want to talk about, and I'm going to keep this really high level, so please ask questions at the end if you have any. 15 minutes isn't enough time to talk in detail about any of these tools. But I do want to tell you about our Heat Vulnerability Index, which we have at the state, county, and tribal level. These are maps that we've created. So a little background, as part of our work in the Climate Health Program, we were tasked from the CDC with forecasting climate impacts and assessing vulnerabilities, and knowing that extreme heat is such an issue, even in Wisconsin. We wanted to better understand the vulnerability related to heat across the state. So we assembled a number of different data layers, 22 to be exact, into a heat vulnerability index and created a state level map. One of the goals of the project was to use our heat vulnerability maps to help inform public health interventions. Very briefly, we conducted a literature review. We found that San Francisco had already created a heat vulnerability index, and we copied their methodology. We created a standard methodology and ended up with 22 data layers, like I mentioned. There are a couple fewer data layers for the county and tribal lands HVI maps because of data limitations. And I took out my notes about what all those data layers were, but I did want to mention when Vivek was talking about social vulnerability and impervious surfaces in his talk, that reminded me that there are four main categories of data that goes into these heat vulnerability indexes. And one of the categories is population density. And I believe that takes into account impervious surfaces. And then we also have a whole category of demographics, which takes into account all the various demographics that would go into a social vulnerability index. So those variables are accounted for in these index maps. I wanted to briefly talk about the application of these heat vulnerability indexes. So we've shared them with our partners, and we're hoping that they can use them in their agencies to plan for heat events. For example, these maps could be used to determine where cooling centers should be located and to inform messaging and public health interventions. And we have actually, at the Climate Health Program, used our own prior research to inform where we conducted our prospective extreme heat-related rapid needs assessment, the CASPER, in 2018. So we used our own maps to decide where to conduct that, that rapid needs assessment. Okay. So this is the fourth tool that I sort of snuck in here after talking to Andrea and Janet the other day. We did create a series of cohorts of mini grant pilot projects that we funded between July of 2014 and September of 2016. And you can see where those counties are located on the map on the right. And we worked closely with each of these pilot projects to create a community engagement process in which each community identified what climate-related health impacts are of greatest concern to them in their particular community, what adaptation strategies seemed most feasible, and then coming up with action plans for implementing these adaptation strategies. Now, I mentioned this toolkit because, or this project, because the end result was that we made a toolkit documenting our process, knowing that we weren't going to have additional funding moving forward to fund local health departments. We wanted to document our process and encourage other local and tribal health departments to conduct this community engagement climate action planning work. So this is available on our website, and there's an accompanying PDF workbook that goes along with it that anybody can use. So I encourage you to check that out. So then finally, I'm gonna check my time here. Okay. The final project I wanted to talk to you about is this prospective extreme heat rapid needs assessment that we did. It's the Community Assessment of Public Health Emergency Response, or CASPER. And I just want to mention that CASPER doesn't work for everyone everywhere. This is just a type of rapid needs assessment. I'm not recommending you use this particular methodology. It's actually quite rigorous and can be tricky. And I don't know that it's this type of strict, rigorous methodology is absolutely necessary for all the types of projects that you might want to conduct. So I just want to put that out there that this is what we did, but I'm not saying that this is what you have to do. But rapid needs assessments are really helpful to learn about the needs of your community. So I will encourage that. So we, along with local partners, piloted a tool developed by the Centers for Disease Control and Prevention called the Community Assessment for Public Health Emergency Response, or CASPER, which is an epidemiology tool that's used to rapidly gain information about the needs of a community. It was originally developed to be implemented after a disaster, such as a hurricane or a flood. The information can be used to determine critical health needs or the effectiveness of relief efforts of an affected community. The data is collected by going door to door to administer a short 10 to 15-minute survey. In recent years, the methodology has also been used prospectively for preparedness CASPERs, and this particular project was conducted in a non-disaster setting and on the topic of extreme heat preparedness, and this was the first CASPER to ever be conducted in Wisconsin. It was conducted in mid-September 2018 in the city of Milwaukee, Wisconsin. And again, we conducted the CASPER there based on our heat vulnerability index in prior years, which indicated that Milwaukee, Wisconsin is one of the most vulnerable geographies in Wisconsin during an extreme heat event. We chose to conduct a CASPER for multiple reasons. We wanted to build capacity at the state and local level for future CASPER implementation. We wanted to better understand levels of knowledge, ability to cope and respond during an extreme heat event. And we wanted to inform future extreme heat plans in Milwaukee, Wisconsin. The data results and findings have been shared with multiple audiences, including the Milwaukee municipal officials, to inform extreme heat planning and communication about extreme heat events. Milwaukee community groups to increase local knowledge of how to cope and adapt to extreme heat events, and internally in the Wisconsin Department of Health Services to help build capacity for future CASPER implementation. So in the interest of time, I just picked a few key findings from our CASPER survey results to highlight because I found them interesting. So from the survey, we learned that only 9% of households had no air conditioning. However, even though a pretty high percentage of households have some form of air conditioning, half felt too hot inside their home sometimes, most of the time, or always. And these findings suggest that the air conditioning that many of these folks have isn't sufficiently cooling their home. 32% of respondents experienced symptoms due to heat in the past summer, and another notable finding was that 63% of households did not know the location of a nearby cooling center, which suggests that more work could be done to increase that awareness. We also found that the term cooling center was problematic for a variety of reasons, so I could talk about that for a long time now. So yeah, this is just summarize my presentation. I just wanted to wrap up by sharing a summary of the tools. Again, I think Andrea will be sharing all of these with you. They're all publicly available on our website. You can download them. You can post them to your organization's Facebook page or website. Feel free to copy them and make them useful for you. And yeah, I just want to reiterate that please do get in touch with your local public health agency or state public health agency if you are working on making plans, extreme heat plans, or responding to extreme heat events, just making sure that you're taking COVID-19 into account for that work. Wanted to acknowledge and thank the Climate Health Program team, which I am no longer a part of, sadly, after 7 years of being part of it. The current Climate Health Program manager who just joined our team about 6 weeks ago came back to us after having been an intern many years ago. She has been working in preparedness, and because of that has been 24/7 COVID, which is why I'm giving this presentation. Erica Klutenmeyer, who's our comm specialist. We have a Pop Health Fellow, Tenny Yangdren, and our Chief Medical Officer, John Myman, who is also 24/7 COVID, so I haven't seen him in months. And Roy Irving is our section chief. So I just want to acknowledge and thank them. They make up the Climate Health Program these days. And feel free to reach out to me with any questions. Though this is no longer my role, I am very available to answer any questions related to anything I talked about today or anything climate health related. So please check out our website and feel free to reach out to me. Thank you so much for your time, and hopefully we have time for a few questions. I will stop sharing my screen now.
Thanks to you both. That was great, incredibly informative. I'm sitting here having brace envy. It's amazing what you can do with a dedicated team and resources. So please go ahead and either put a question into the chat box. It looks like there's one here, which I can read, and oh, they're coming in. So we do have a little bit of time. So Jim asks, let me read the whole thing. Given recent protests, et cetera, we can assume that violence between first responders and citizens, between citizens and protests, et cetera, will surely increase as climate destabilize. However, do you know of any research going on connecting rising heat, along perhaps with other climate impacts, to increased violence, perhaps even violence by first responders, especially police? So I'd offer that to Colleen or Vivek.
So I don't have a good answer to that. It's a great question, though. I do know that there is research linking violence and extreme heat. There's historical research on that. I don't know of any recent research related to the current defunding the police and protests that have been occurring in our nation. That's something that now I'm going to have to look into. But yeah, I don't know of any very recent research on this, but there's definitely a link between extreme heat and violence.
Yeah, oh, sorry, Vivek, go ahead.
No, go ahead, please.
Well, I was just going to say that I can second that because I've actually looked at some of that research, and we'll try to find a site or two and get that out to the group. Vivek, did you want to add something?
No, this is a field that actually first got me interested in, this is an area that got me interested in heat originally. I just say that there is, our bodies are, respond to stress in a variety of different ways. I've come to understand, you've heard of the fight or flight idea, but it is really kind of ingrained in us evolutionarily. I would, surmise that this response to stress, heat is an incredibly potent stressor. And it's one of those things where we don't often know that we're stressed because our body is so busy kind of thermoregulating and coping with it in the best that it can. And so a lot of the fatalities that we see is because often people don't even know they are stressed in that sense, and they're sleeping many cases, and it's overnight heat in their homes that we've seen some research come out about. And so I just link it back to the whole much larger question of stress and our ability to respond to it, and how our bodies each respond differently. And it overwhelmingly seems to suggest that violence it's not a causal relationship, but it is a means by which the body attempts to cope.
I have to say that I'm having flashbacks to the Marlon Brando movie, Streetcar Named Desire, where it's very hot in that movie down in New Orleans, and there's violence simmering under the surface of every scene. Heidi asks, when coordinating ground-based measurements with our local community, how do we connect with marginalized groups that are the most vulnerable to extreme heat? That's a great question, Heidi, thank you.
Yeah, maybe I'll take that one. If there's other thoughts on this, I'm open to it. But there's multiple avenues by which we've found success in being able to engage communities who've historically not either participated in climate-related activities, participated in environmental activities, or in any kind of at least city-sponsored activities. And one approach that we've leaned on more than anything else is working with local trusted organizations, and that has it's not necessarily that there's those relationships that are created already, though if someone is planning, let's say, a summer 2021 heat campaign, then part of what we've found to be helpful is to start developing those relationships with community-based organizations well in advance. So it's not kind of a research and retreat model. We really believe in sticking around for the long term, really wanting to support community and building the trust, because until that's done, it's going to be really hard to really get through some of this stuff, which I'll just quickly add that there is a long history of distrust between, any kind of state or city or federal sponsored program and communities that have been historically marginalized. And so the first step is really building that trust, and then recognizing that there may be a lot of learning to be done on all sides, and a lot of listening certainly to do on all sides. And then by building trust, I think the elegance and implementation of the toolkits, as well as the engagement, really follows.
Yeah, and if I can quickly jump in and add to that. So one of the things I didn't get to mention for purposes of time is that with our CASPER, or Rapid Needs Assessment, we spent a year and a half planning that and working with local community partners, one of whom is a federally qualified community health center and clinic, 16th Street in Milwaukee. And then also we worked very closely with Unite MKE, which is a local community health worker organization, because we felt that that trust issue that Vivek is talking about, we wanted there to be our pairs of surveyors going and knocking on doors. We wanted one of those team members to be from the local community. So we partnered with Unite MKE to make sure that there was a community health worker from the neighborhood who was paired up with a public health practitioner to go and collect that data. And I would just put a plug in for working with community health workers, because they know their community, they live in their community, they are trusted entities. So if you don't know what that is, look it up, because we're out of time already. But check out community health workers and get to know them. And I can't reiterate more what Vivek said about building those relationships with trusted community partners is really the route to go, and listening, because we only know so much. We don't know the communities. So just stepping back and listening and learning before making any plans or moving forward with any of your projects.
Yeah, that's super good advice. So there are 3 more excellent questions, and I just can't bear not putting them out there. So hopefully people will be able to hang over for just a couple of minutes for some quick answers from our speakers. The first is from Brian to Vivek. What's the best way to engage local governments to take incremental action to address climate change as it relates to heat? For example, planting more trees. Governments seem slow to respond.
Is that to me?
Yes, it is.
Okay.
But either of you could answer.
I'm not seeing it in the chat window here, but
Oh, it was just sent to me privately
okay,
for whatever
okay.
reason.
And I think I got, what's the quickest way to respond?
How do you persuade local governments to actually take action? They seem so slow to respond, to which
Yeah,
many on this call may say amen.
Yeah, that may be so much about kind of building the groundswell to engage in this conversation. So working with local, again, I'm a big proponent of working with trusted local organizations. We worked, for example, with a Oregon Museum of Science and Industry, so a local science museum, to kind of advance the conversation by doing workshops. We're certainly involved in engaging community members in testimony, in public testimony at city council meetings, when we are talking about things like tree planting that connects, when we're talking about or public health that connects, as where we're talking about land use decisions or climate action plans or climate resiliency plans. Like, this is a very integrative concept, and to kind of see it as that, it has tendrils into lots of different actions that are currently underway. And if we're not taking it into account, particularly as we put in buildings and things like that that have 50, 80, 100-year time horizons, it can really be unwieldy to try to back into retrofitting or redesigning buildings once they're put in the ground. So really working at the groundswell of activities that's currently already underway.
Yeah, I'd also add that you can find strange bedfellows. So who else is interested in planting more trees? It may be people who aren't thinking about climate change at all, but they're strong advocates for whatever the approach is. So David asks whether either of you have worked with electric utilities to improve their policies related to customer disconnections during extreme heat events.
I personally have not engaged in those conversations, but it has been a topic that has come up because in Wisconsin, I believe there's a similar understanding with many of the utilities to not turn off heat during the winter. And so the conversation is then how is extreme heat different in the summer? So I know those conversations are starting to happen, but I personally haven't had them yet. But it's a great question, and that work needs to be done.
Yeah, I don't have a solid answer for that either. It is an area that's just early, along with this air conditioning question. We really don't know the extent to which air conditioners are being used, and what Colleen was saying about these survey results, like, that's entirely emerging information at this point. And in my job at the university, I have a couple of PhD students actually looking at AC use and its role in terms of future projections for the infrastructure systems that we've designed that may not be able to withstand the demand that we're seeing come up right now.
Well, I happen to know that David, this is an area of research that David focuses on quite significantly. We also just recently did through IU something called the Hoosier Life Survey, where we surveyed several thousand Hoosiers about various things related to climate change. And the vast majority of them say that they have and use air conditioning, which is that's a good thing to know that most people have it, but of course it costs money, and the risk of having it turned off when you don't have a job is present for a lot of people. Jennifer asks, are the speakers aware of any data or sources that speak to the return on investment of the financial investment into projects that address extreme heat, recognizing that governments have to justify their capital expenditures, usually by showing the return on investment?
Colleen?
I don't know of an ROI specifically on this topic. I know the NRDC put out some papers in the past year about the economic impacts of climate change, but I don't know of an ROI specific to this, but this again is an area of research we're really interested in learning more about. In fact, we're having a conversation internally a couple of weeks ago about the need for increasing our capacity, our evaluation capacity within the Division of Public Health, and how we want evaluators who know how to do ROI as well, how to evaluate that as well. So, we're a state agency, we're not an academic institution, though most of us are would like to think that we are. But yeah, area that we need to learn more about. So I'll turn it over to Vivek now and see if he knows more about that.
Well, I've tried to connect with several economists who work on this issue, and it is an area that I think has enough data right now to be able to start looking at broad trends. We saw a recent report come out from CDC about the implications for the number of excess mortality, morbidity, but then what this ROI is about is like, how can you show, similar to the previous question, how can you show council electeds that this is really something that will have long-term, even short-term investment returns? And so
right.
The cost of death, needless to say, is very high. That's probably kind of overwhelms a lot of the other more incremental components of this, such as energy. I had a master's student look at energy use at individual household for 250,000 households in the Oregon area, and we found that that two households that are essentially the same, one that's in a hotter area, meaning it's about 15 degrees hotter at the same time, pays about $750 more per year in cooling costs if they're running their AC than in an area that's much cooler. Same house, same design, same time frame. And so this has a potential effect on pocketbooks and return on investment as well. And then, of course, the way we go about designing developments is something we're spending a lot of time on.
Great.
Keep it short.
Well, yeah. I mean, if there's any citations to material that you could provide to us, that would be great, and we'll send them out. So the last question from Laylee, I hope I pronounced your name right. What do we know about the difference between temperature and temperature feels like? Because the latter may have important health indications during extreme heat. Temperature feels like.
Colleen, you want to take that?
Do you want to field this one?
We do this.
I'll let you.
Okay. We do this just in a nutshell. We do this a lot. There's a technical question in terms of including or not including humidity. So there's many different ways to do this, and this is a whole field of research in and of itself. But our simplest way of doing it is when we collect temperature, we also collect temperature and humidity, so that when you get this combination, you get what's essentially called a heat index. And that heat index and thermal comfort allows us to better describe those thresholds at which the body is no longer able to cool itself. So that's usually about 13 degrees Celsius or 98.6 Fahrenheit. And those are thresholds where you reach this wet bulb temperature, and that's quite a significant impact on human ability to cope. And so the humidity, or the temperature feels like, is an essential part of the calculation, with at least with respects to our ability to sweat and cool off.
All right. Well, you should all be seeing an important, urgent poll on your screen that gives us important feedback. So please take a minute and vote. The votes are coming in. We won't close off the call before people have had a chance to vote. I want to thank our speakers, Colleen and Vivek. This has been really, really informative about a really important topic. So I've just got a zillion little reminders to myself of resources that we ought to run down. I want to wish everybody a safe and healthy August. Stay cool. And I get lots of work or relaxing or both done so that you can be refreshed in August. That's what we plan to do, and taking a month off. And we'll look forward to providing you with a big old roster of really interesting webinars starting in September. Andrea, any last words from you?
I don't think so. We've got a good response, so I think we're ready to close out.
All right. Goodbye, everybody. And thanks again for joining us today.